Here is another example involving percentage error. It's a bit different from the previous example that we looked at, where we looked at the length of a room and the room was measured to 4.1 meters, but with two different measuring instruments, obviously with two different accuracies or two different precisions. This example uses the same measuring instrument, okay, with the same precision but two different measurements. So the length of the Sydney Harbour Bridge was measured at 1.1 kilometres. The length of the Golden Gate Bridge, okay, was measured at 2.7 kilometres. Okay, so the Golden Gate Bridge is in San Francisco, was measured at 2.7 kilometres. Calculate the percentage error of both measurements. Okay, so both of these bridges were measured using the same measuring instrument. Okay, so let's have a look at the percentage error of the measurement of the Sydney Harbour Bridge. Okay, so we'll do that one first. So Sydney Harbour Bridge. First thing we need is the precision. Okay. In fact, the precision for both will be identical because it's the same measuring instrument. So the precision is 0.1 kilometers. Okay. So that's the smallest unit of measure that the measuring instrument can in fact measure. It can measure accurate to 0.1 kilometers. Okay. Absolute error. In fact, the absolute error will be the same for both as well. Okay. So absolute error is equal to half of the precision. So that's going to be 0.05 kilometers. Okay, so now we can work out the percentage error. Okay, is equal to the absolute error, which is 0.05 over the measurement, 1.1, and we're going to multiply that by 100 to get it as a percentage, and that value will be 0.05 over 1.1. We're going to multiply that by 100 and we get 4.5%, or let's say two decimal places again, 4.55. Okay, so let me just see, that's the calculation there. Okay, 4.55%. Okay, so let's work out now the percentage error of the measurement of the Golden Gate Bridge. Okay. Okay. Now we're going to use the same precision and the same absolute error since it's the same measuring instrument. Okay, so percentage error. Okay, it's 2.7. Okay, oops. 0.05 over 2.7. Okay, multiply that by 100. Okay, you could just recycle the same calculation, so rather than entering it in all from scratch, you could just scroll back and basically replay the calculation but just change the denominator. So it's going to be 1.85%. Okay, so it seems that the same measuring instrument, okay, so they're the two values. It sounds like the same measuring instrument obviously is more accurate measuring a longer distance than it is measuring a shorter distance. So if I was to use the same measuring instrument then to measure the length of a major motorway that could span 100 kilometers, for example. In fact, if you wanted to do that, I can quickly show you. Okay, using the same absolute error, let's say you were measuring a road that was 100 kilometers long, multiply that by 100. Okay, the percentage error will be 0.05%, again in contrast with these values. So clearly, this for the same measuring instrument, the longer the measurement, the better the percentage error, or the more appropriate that measuring instrument is for that application. Okay, so there's many rules as to which what would be the threshold for for a good percentage error or not. Some people would argue 1%, anything above 1% is bad. You need to use a better measuring instrument. Some would argue 5%. It really depends. So there's no real, I guess there's no real hard and fast rule on what is a good percentage error. But definitely, the lower this number, the better.